Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about beta distribution, and if our random variable x here has a beta distribution, therefore its probability density function is described by this equation right here. So you can see that the probability density depends on alpha and beta. There are two parameters here. And the values for our random variable, x here is our random variable, and it takes values from 0 until 1. Now, why is that values are given as such? Because usually when you talk about a beta random variable, this sort of variable represents the outcomes for percentages or proportions. And usually that's why the values are between 0 and 1. Okay, and you will see that some students might also get confused with the name beta itself, because in this beta distribution we have the word beta that represents three different things. So the first one is beta as in the name of the distribution, so we got the name of it. And then we also have beta that represents the shape, the second shape parameter. So that is another beta. And then we also have another beta, which is the name of a function. This is something similar to gamma function. If you have seen my video related to the gamma distribution, you will remember that there is a gamma function before we go on and talk a little bit more about gamma distribution itself. So here beta in this third scenario here represents the name of a function, which is similar to the idea of gamma function. Recall that in that video related to gamma distribution, there is a difference between gamma function and gamma probability density. Okay. So I think it is appropriate that we talk about beta function first before we move on to looking at example and so on. Yeah, and here is a little bit of notes related to beta function itself. Before I continue explaining this, you might want to pause the video right here and maybe perhaps go through each lines and get some sort of idea of what is it all about. And then I'm going to discuss what is the essential point given on this page. Okay. Right, assuming that you have done just that, okay, you have paused the video, you have looked at all the points given here. Now let's start our discussion about beta function, okay? First of all, what is, we're going to start off with the probability density. Okay, we're going to write down the probability density function if our x here has a beta distribution. So x has a let me just write down this notation. So our random variable x has a beta distribution with parameters alpha and beta. Therefore, the probability density of that is given by this expression here. We have gamma alpha plus beta, gamma alpha, gamma beta. And then we have x alpha minus 1. And then we have 1 minus x beta minus 1. So that is our probability density. Okay, so that is our probability density. And we know that if we take this probability density and we integrate this function from lower limit to upper limit, the result is going to be equal to 1. Why is that such? Because that is the characteristic of a probability density function, which you have learned in chapter 3. So if you consider integrate this function, so we're going to integrate this function with respect to dx from the lower limit is 0 until 1. So if you integrate this density function, the result is going to be equal to 1. Okay, and in this process here, you can easily see that this part right here is constant, which you can take out from the whole process really. So you can take it out. So that becomes gamma alpha plus beta over gamma alpha gamma beta 1 0 x alpha minus 1 1 minus x beta minus 1 dx is equal to 1. Okay, now we're just going to try and let this be the subject. So this is going to remain on the left hand side of the equation. We're just going to have this alone on the left hand side. So the rest of it is going to disappear and it's going to be somewhere here on the right hand side. Okay, so that's what we're going to do now. Therefore we have this guy, alpha minus 1 1 minus x beta minus 1 dx. This is going to be equal to gamma alpha gamma beta over gamma alpha plus beta. Okay, so basically that's what's going to happen, because we consider this thing disappear on the left hand side. So if you want to get rid of it, that means you're going to multiply with gamma alpha gamma beta over gamma alpha plus beta, where you can cancel out. So if you multiply the left hand side with this term also has to be multiplied right on this right hand side of the equation, right? So here we've got 1 multiplied with that, and that's why we got the result right here. Okay, now this is what we call beta function. The whole thing here, this is beta function, and the result of the integral here is just this one. So this is the result of integral. So next time whenever you see this integral, this function here being integrated from 0 to 1, you don't have to do the integration process like you usually do. You're just going to apply this result right here, and this result here is useful because we can use it easily to prove the expected value of a random variable x and variance of x. We'll be using this information here related to beta function in order to prove, or in order to find what is ex and variance x when x has a beta random variable. And that one I will discuss it further in the next video, so we're just going to leave it at that first. Well, for this one here, let's just look at some practical examples, but before that, let us look at some graphical examples on its probability density function, where you can see that different values of the parameters here will give different shapes for the graph. Okay, so that's the idea. When you change the values of the parameters, then the shape of the graph will also change accordingly. Here we've got the mean given by this result, alpha over alpha plus beta, and the variance is given by this result. And the above statements can be easily proven if you are able to manipulate the information related to beta function. So again, this part here is important. This is the part where you talk about beta function, and you will need this part here when we try to prove the result of expected value of x and variance of x, and that you will see in the next video. Okay, right, for this one here, we're just going to try and solve a practical example related to a beta distribution. Here we've got DVDs in a certain shipment are defective with a beta distribution where the probability density function is described as follows. So this is the PDF of a beta distribution. So here alpha is equals to 2, alpha is equal to 2, beta is 5. Now compute the probability that the shipment has between 20% and 30% defective DVDs. Right, so in this example here, we can say that our random variable x here represent the percentage of defective shipment. And you can see when you talk about percentage, that means our x here can take back values between 0 and 1. So this is a beta distribution. It has a beta distribution right here. And the question is asking you to find what is the probability that x is between 30% and 20%, which can be changed to values such as probability it is between 0.2 and 0.3. So that is what the question is asking you to do. And in order to do that, we need to integrate the probability density function here from 0 to 0.3. So these are the limits according to the information given by the question. The question is asking you to find the probability between 0.2 and 0.3. Now, what is alpha plus beta? So that would be gamma of 2 plus 5 over gamma 2, gamma 5. Okay, so that is this part. And then what is x? X is with alpha minus 1, which is 2 minus 1, 1. Okay, and then we have 1 minus x. So beta is 5, 5 minus 1 is 4. Okay, next we can see that this is the constant. You can just take it out from the integration process. So we have 7 gamma 2 gamma 5, and I'm just going to now change the representation of this to something else. I'm going to let y represents 1 minus x, because then it will be easier. We don't need to expand this. We have 1 minus x to the power of 4. It will be difficult to expand this, so I'm just going to call 1 minus x equals to y. Just going to make my life easier. Okay, therefore if 1 is equal to 1 minus x, x must be equals to 1 minus y. Okay, now we're going to use that. I'm just going to integrate that. I don't bother with the limits first. Just going to replace x with 1 minus y, and this one is equal to y to the power of 4. And what is dx? Well, if y is equal to 1 minus x, if y is equal to 1 minus x, dy dx is just 0 minus 1. Therefore, dx is just negative dy. Okay, so dx is just negative dy, right? So I'm just going to replace dx with negative dy. So here we have negative. I'm going to put it here, and dy. Okay. Right. Next is what is the result of gamma 7, gamma 2, and gamma 5? This one we need to have we need to apply the properties of gamma function. So if you have gamma 7, it is the same thing. You can find the result here by finding 7 minus 1 factorial, which is 6 factorial. So gamma 2 is 2 minus 1 factorial. If you don't know what is this really, you need to refer to my video related to gamma distribution. Okay, and then gamma 5 is just 5 minus 1 factorial. So let's just write down the result. Well, we have 6 factorial over here is 1 factorial times with 4 factorial. And right now we can expand this part. so it becomes negative y to the power of 4, and then we have plus y to the power of 5 dy. Okay, now what else? Okay, let us erase this part because I need the space. Okay, next what we can do is for this part here, we know what happens when you integrate this part here. The result here is going to be negative y to the power of 5 over 5 plus y to the power of 6 over 6. But what is y? Y is actually 1 minus x. Just now we let y to become 1 minus x. So I'm just going to substitute 1 minus x back into y so that I can then apply the limit related to x, which is from 0.2 to 0.3. Okay, so that's what I'm going to do next. Now this is equal to first 6 factorial, 1 factorial, 4 factorial. That one can be cancelled out, so you will be left with 6 times 5 at this outside here, because it can be cancelled out with 4 factorial at the bottom. Yeah, 6 times 5, let me just write down in terms like this, and then we will have the result here, negative y to the power of 5 over 5. So we have negative y is 1 minus x to the power of 5 over 5, and then we have plus 1 minus x to the power of 6 over 6, and that will be evaluated from 0.2 to 0.3. Okay, now the next one is we are going to have this result is equal to 30. If you want, you can take out this negative outside, so we have negative 30. And inside here, it will be changed to 1 minus x to the power of 5 over 5 minus 1 minus x over 6, this one, okay? I'm just using this representation. Take out the negative from it, so here it becomes positive, but here it becomes negative, yes? Okay, so next what we're going to do is we're going to substitute 0.3 into x. So 1 minus 0.3 is 0.7 to the power of 5 over 5. Next 0.3 into here, so we have negative 0.7 to the power of 6 over 6. Okay, so that is the first part when you substitute 0.3. Next, you're going to minus, substitute 0.2. So 0.2 into x is 0.8 to the power of 5 over 5 minus 0.8 to the power of 6 over 6. Okay, right. Now this space here is a bit tight, but I hope you can see what's going on here. Now if you punch in the values into your calculator, for this part here, you should be able to get the result is about 0.01401, and for this one here, it will be about 0.02185. Okay, and finally when you multiply the result here, subtract and so on, you will get the final answer is 0.2351. so this is the probability that the shipment has a defective. The percentage of defective is going to be between 20% and 30%. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video, and we're going to discuss this part right here. How can we prove expected value of x is this one and variance of x is this one. Alright, see you then.